In these problems, we're comparing linear to exponential models, and we might as well write the equation of each one while we're at it. Linear equations are the equation is y equals mx plus b. Exponential equations, y is equal to a times r raised to the x, where a is where it starts and r is the factor. You can tell which one is which because a linear equation adds the same amounts each time, and an exponential equation multiplies by the same factor each time. And when I say each time, I mean each time x increases by 1. So how much does y add? Adds and amounts m. So m tells you how much it adds each time. So if m, for example, were 3, it would mean that every time x increases by 1, then y would increase by 3. So it starts at 7 and it would increase by 3 every time. 13 and a little bit of an emergency there. So every time x goes up by 1, then m tells you how much it increases. So if m was 3, for example, the amount that you add each time would be 3. M tells you the amount that it goes up every time. Or down. I don't mind saying adds because it could be that it adds a negative. So linear functions add the same amount each time, and that's m that tells you what you do that because it's m times x. And then this function multiplies by the same factor each time. The factor is r. And so just the same way, if r was 3, that would mean you multiply times 3 every time. So if you started with 7, it would go 21, that's times 3, 63, that's times 3, and so on. So linear functions add the same amount each time, and exponential functions multiply by the same amount each time. And if that did not sink in, although honestly the best thing to do is to ask yourself, like, does this mean that the car decreases by multiplying by 10,000 each time, or does it mean that it minuses 10,000 each time? Use your common sense. That's really the best way to do it. However, you can also look for keywords. The keywords for linear are each, every, and per. And the keywords for exponential would be things that mean multiply, like factor, percent, doubles, triples, and so on. Anything that means multiply is exponential. So this first one, he has a rare coin worth 550, and each year it decreases by 10%. This is exponential, and just for fun, we can go ahead and model that. It starts at 550, so that means A is 550. Again, the equation is going to be A times r to the x, so now we need to figure out what the rate is. If it increases by 10%, then r is 110% of its original value, which means that every time, every year that goes by, this value gets multiplied by 1.10, or just 1.1, and I got that by moving the decimal place 2 times. So the equation that models the coin here is y equals, the value of the coin is equal to 550 to start with, times 1.1 raised to the x, where x is the year. So that's the first equation. The second equation, this is exponential. The second equation, he bought the car for 130,000 pesos and it decreases by 10,000. That's linear. Each is what the slope is, so every year it goes down by 10,000. This one is y equals mx plus b because it's linear. And I need to know a couple of things. I need to know how much it starts at. He bought the car for 130,000. And I need to know how fast it changes, and it changes by decreasing by 10,000 every year. And so the equation for the value of the car is equal to 130,000 to start with minus 10,000 every year. Okay. So I've got one linear function here. It was the one that decreased by a constant rate because I was adding negative 10,000 every time. And then this one was exponential because I was multiplying by a rate of 1.1 every year.